Hi folks, today I have a lesson for you on organic reaction pathway to convert propane into propanone. Alright, so I have a chart here which shows us the common organic reaction pathways, and today's lesson we are starting with propane. So let's find propane or an alkane. Alkane is right here, and what we want to do is we want to convert this alkane into a ketone, which is a propanone, which is right here. So since we have the initial reactant and we know where we want to we want to produce, we will have to figure out a pathway to convert our alkane, which is our propane, into a ketone, which is a propanone. So if you look at the alkane, we cannot go directly to alkene. The arrow is not going towards the alkene. So to go for an alkane to an ketone, we have to create a pathway. We have to go from alkane, and then we will have to go all the way across to form an alkyl halide. Okay, so that's going to be our target. So first we'll convert our alkane into an alkyl halide. All right, so let's start with that. So our alkane here is propane, so I will write propane at the bottom. And our propane is going to be converted into an alkyl halide, but to do this we have to add heat, and so we are going to add heat here, and this is going to, and we will have to add a halogen. So this is going to convert into an alkyl halide, which is going to be, let's say it was HBr we were adding, so it will have bromo. So 1 bromo propane, or the bromine that we are adding could go into the position 2, and therefore it would become a 2 bromo propane. So our alkane, our propane, can convert into two different kinds of alkyl halides, the bromopropane. One is 1 bromopropane and the other one is 2 bromopropane if the bromine attaches to position 2. Once we have the alkyl halide, then we can use that to convert that into an alkene right here. So we are going to go this way and we are going to create an alkene. And to do this, we will have to again have, it says OH minus hydroxyl ions in alcohol with an alcohol. So we will have to use this, and now we are going to use OH minus from the alcohol. Right? So the source of OH minus could be an alcohol or a base. So in this case, we are using alcohol, and this will help us to convert our 1 bromopropane into an alkene, which would be a propene. And the same thing, if it was 2 bromopropane, it will do the same thing, same conditions, OH minus from alcohol, and it will convert into a propene. Now we have converted our alkyl halide to alkene. Now next step, to going down to ketone, we will have to convert this alkene into an alcohol right here. So let's do that next step, and this will happen with the addition of water in a basic condition, and an acidic condition with H2SO4. So let's add H2O, H2SO4. So those are the conditions. We're adding water, and therefore now the OH. So we have two groups, OH and the H. One of the places, one of the carbons will get the H across the double bond, and the other the OH. This will yield the production of 1 propanol, or it can also produce 2 propanol. Depending on where the hydroxyl goes. Now, 2-propanol is going to be the major product because the hydroxyl group is going to the position where we have the carbon with less hydrogen attached to it, and therefore the 2-propanol should be in higher amounts, 1-propanol should be in lower amounts, but we will get two products here, two different kind of products, 1-propanol and 2-propanol. Once we have the alcohol, then we have to undergo an oxidizing, we have to add an oxidizing agent. And if you see in the graph, we have to go from alcohol down to ketone, that's our target, and we have to add for that a mild oxidizing agent. So we will add an oxidizing agent right here and right here, for example. And which one will produce the ketone? Well, if we add an oxidizing agent to 1-propanol, the hydroxyl group is on position 1. And if we undergo an oxidation reaction, the double bond to the oxygen will be in position 1, which means it's at the end of the molecule, and this would result in the production of propanol. Whereas 2-propanol, the hydroxyl group is on position 2 in the middle of the molecule, and if that undergoes an oxidation reaction, it will yield in the production of propanone, because the carbon double bonded to the oxygen will be in the middle of the molecule, and hence we will produce our ketone. So just for a recap, what did we do? Well, we started with our propane, and from the propane we were able to make an alkyl halide, which is either 1-bromopropane or 2-bromopropane. Then we had a hydroxyl group from alcohol added, and that yielded a production of propene and alkene. And after the alkene was produced, we went through an addition reaction to add hydrogen and the hydroxyl group across the double bond, and we were able to produce 1-propanol and 2-propanol. And when these undergo an oxidation reaction, and we are interested in making the ketone oxidation reaction right here, we will be able to make our propanone. I hope you liked this lesson and you were able to learn how to convert a propane into a propanone.